You saw from the last two videos that some AI products may require a large AI team, maybe with 100 engineers or sometimes many more than 100 to build. What I'd like to do in this video is share with you the typical roles and responsibilities of a large AI team like this so you can better understand the types of work needed to build these complex AI products. Now, even if you will be working in a much smaller team, maybe a 1 or 2 or 5-person team for the foreseeable future, I hope this video will still be useful to you because I hope give you a sense of the different types of work that an AI team might need to do, even if you end up executing on this type of work with a much smaller team. One caveat, because AI is evolving so fast, the job titles and roles and responsibilities are not yet 100% defined, and they are a little bit different across different companies. So your company may use the job titles differently than what I'm presenting here, but I want to share with you how job titles are often used in many companies so that if you're someday building up your own AI team or you hear about these roles, you would have at least some default understanding of what these job titles mean. So let's get started. Many AI teams will have software engineers in them. So for example, for the smart speaker, we needed to write specialized software to execute on the joke or to set a timer or to answer questions about today's weather. So those are traditional software engineering tasks. Or if you're building a self-driving car, to make sure that your self-driving car software is reliable and doesn't crash. These are software engineering tasks. So it's not uncommon for AI teams to have a large fraction, sometimes 50%, sometimes much more than 50% of software engineers in them. The second common role is the machine learning engineer. And so a machine learning engineer might write the software responsible for generating the A to B mapping or for building other machine learning algorithms needed for your product. So they might gather the data of pictures of cars and positions of cars, train a neural network or train a deep learning algorithm, and work iteratively to make sure that the learning algorithm is giving accurate outputs. Another role that you sometimes hear about is the machine learning researcher. The typical role of the machine learning researcher is to extend the state of the art in machine learning. Machine learning and AI more broadly are still advancing rapidly, and so many companies, for-profit, non-profit, will have machine learning researchers responsible for extending the state of the art. And some machine learning researchers will publish papers, but many companies also have machine learning researchers that do research but are less focused on publishing. There's one other job title that's sort of in between these two, which is the applied machine learning scientist, which lives somewhere between machine learning engineer and machine learning researcher. And the machine learning scientist kind of does a bit of both. They're often responsible for going to the academic literature or the research literature and finding the state-of-the-art techniques and finding ways to adapt them to the problem that you're facing, such as how to take the most cutting-edge trigger word or wake word detection algorithm and adapt that to your smart speaker. Let's look at some more roles. Today, there are a lot of data scientists working in industries, and the role of data scientists is not very well defined, and the meaning is still evolving today. I think one of the primary responsibilities of data scientists is to examine data and provide insights, as well as to make presentations to teams of executives in order to help drive business decision making. There are also data scientists today doing other tasks. So there are also data scientists today whose work looks more like the machine learning engineer that I described on the previous slide, and the meaning of just job title is still evolving today. With the rise of big data, there are also more and more data engineers whose main role is to help you organize your data, meaning to make sure that your data is saved in an easily accessible, secure, and cost-effective way. So why is saving data such a big deal? Can't you just save on a hard disk and be done with it? In some companies, data volumes have gotten so big, there's actually quite a lot of work to manage them. To give you a sense of the scale, in computer science, 1 MB stands for 1 megabyte. And so a typical song on your music player, like a typical MP3 file, may be a few megabytes, say 5 megabytes would be a not unusual MP3 file size. 1,000 megabytes is called a gigabyte, 1,000,000 megabytes is called a terabyte, and 1,000,000,000 megabytes is called a petabyte. With today's hard disk sizes, saving a few megabytes is not a big deal. It's just like a MP3 file. But storing 1,000 megabytes, also called a gigabyte, starts to be a bit slower. A typical hour-long movie that you stream over the internet may be about a gigabyte. So that's quite a lot of data. And to give you a sense of the scale, a self-driving car may collect multiple gigabytes of information every single minute of operation. So it's as if every minute the self-driving car generates enough data to store multiple hour-long movies. So self-driving cars actually generate a lot of data, and saving the data from many days or weeks or months or years of operation starts to require serious data engineering. A terabyte is 1,000 times bigger than that, and a petabyte is yet another 1,000 times bigger than that. I've led teams that were responsible for saving several petabytes of information per day, but other than pretty large internet companies, it's not that common for a company to generate multiple petabytes of information per day. And as you move down this scale to bigger and bigger data sets, it becomes harder and harder to make sure the data is stored in an easy, accessible, secure, and cost-effective way, which is why data engineers become more and more important. Finally, you also hear some people refer to AI product managers, whose job is to help decide what to build. In other words, to help figure out what's feasible and valuable. Traditional product managers' job was already to decide what to build, as well as sometimes some other roles, but the AI product manager now has to do this in the AI era and are needing new skill sets to figure out what's feasible and valuable in light of what AI can and cannot do today. Because the field of AI is still evolving, none of these job titles are completely nailed down in stone, and different companies will use these job titles somewhat differently. But I hope this gives you a sense of some of the different types of work needed to build very complex AI products, as well as where some of the job titles are evolving. To finish though, I want to re-emphasize that you can get started with a small team. You don't need 100 people to do most AI projects. And so whether you just have one software engineer working with you, or just a single machine learning engineer, or just a single data scientist, or maybe nobody but yourself, if either you or an engineer working with you has taken some online courses on machine learning or deep learning or data science, that's often enough for you by yourself or for you and an engineer to start looking at some smaller volumes of data, start drawing some conclusions, or start training some machine learning models to get going. So even though I've tried to paint here a vision for what a large AI team might look like, even if you have only a small AI team, could be nobody but yourself, I would still encourage you to get started and start exploring what are projects you could do. In this video, you saw what an AI team might look like, but when you look at a bigger company, an AI team doesn't live in isolation. So how does an AI team fit into a bigger company to help the whole company become good at AI? You might remember that in week 1, I briefly alluded to an AI transformation playbook, which is a roadmap for you to help a company, to help maybe a great company become great at AI. Now that you've learned what is AI, how to do AI projects, and even what AI teams and companies and complex AI projects and companies might look like, let's return to the AI transformation playbook and go much deeper into the individual steps of the playbook so that you can understand what it takes to help a company over maybe a small number of years become good at AI and hopefully become much more valuable and much more effective along the way. Let's go on to the AI transformation playbook in the next video.